This 3D aquarium was planned, coded, tested, viewed, and repeatedly revised by DeepSeek. The main controls work, the fish respond to food, and no human edited the source code. But before we judge the result, there is a reason this particular test mattered to me. DeepSeek v4 Flash 0731 was already one of the models I found most interesting. It offered strong agent performance at a comparatively low API price. Its open weights also meant that, with enough effort and some serious hardware, local deployment was possible. It was not a tiny model. DeepSeek described the Flash architecture as a mixture of experts model with 284 billion total parameters and around 13 billion active at a time. But compared with the much larger Pro model, Flash was designed to be the faster and more economical option. There was just one thing I found frustrating. It could not see images. For modern agent workflows, vision is not a decorative extra. If an agent is building a website, a game, or any visual product, it needs to inspect what it actually produced. It should be able to look at the interface, notice weak composition or broken geometry, change the code, and then look again. Without image input, DeepSeek v4 Flash could build the product, but it could not directly inspect the pixels and improve them through a visual feedback loop. For the kind of autonomous product work I wanted to test, that was a serious limitation. Now that situation has changed. DeepSeek v4 Flash Vision Experimental adds image understanding while retaining the Flash model's text capabilities and Flash-level API pricing. So I wanted to test the new capability immediately, not with a chart-reading demo, but with a task where visual judgment is part of the work itself. I gave the model a fresh workspace and asked it to build a beautiful, playable 3D aquarium. The player needed to choose fish species, change the layout, place rocks, coral, plants and wood, feed the fish, and see the fish react. The model controlled its own implementation loop. It wrote the source, ran production builds, opened the result in a real browser, captured screenshots, inspected those images, and revised the code. I did not step in to redesign the aquarium or repair its source. It continued until it declared the simulator complete at turn 131. Across that run, DeepSeek made 76 source writes and took 29 browser captures. After seeing its first screenshot, it went back and changed the source 67 more times. The independent production build passed, WebGL rendered correctly, and the final browser capture had no page-level runtime error. Then a human tester exercised the unchanged result with normal mouse input. The practical result was broadly successful. The aquarium could be rotated and inspected. Fish species and counts could be changed. Layout objects could be placed, selected, moved, rotated, and deleted. Feeding caused the fish to converge on the food. In a light human playtest, there was no major operational failure. The water, bubbles, lighting, and glowing reef center also gave the tank a coherent visual identity. But vision did not automatically turn the model into an expert 3D artist. Some rocks extended beyond the glass boundary. The fish were recognizable, but their bodies still looked like simple geometric pieces assembled into fish-like silhouettes. Their orientation was also not always convincing. When food was placed behind them, several fish appeared to move backward toward it instead of turning naturally, which was functional but unintentionally funny. These were not catastrophic defects. The simulator still worked, but they were exactly the kinds of problems a human art director notices immediately, even after an agent has looked at its own work 29 times. So my conclusion is not that DeepSeek Vision failed. It turned a fresh workspace into a working interactive 3D application, used visual feedback to repair it repeatedly, and reached a usable result without human source edits. The new vision capability removes one of the biggest limitations I felt when using DeepSeek v4 Flash for agent work. It can now see the product it is building, and that meaningfully expands what the model can attempt. Considering the price, this is an impressive result, but visually I still want it to try a little harder.